Hi guys, so today we're going to look at something called the fundamental theorem of algebra, and we're going to write equations of polynomials very similar to what we did with quadratics. So to start, we're going to review a little bit of what we did last class when we used the rational root theorem to be able to find all of our zeros. But again, one of the things we talked about is we don't need to use the rational root theorem unless we absolutely have to. It's kind of our last resort. So something like A, if you want to find your P over Q values for 64 in trisynthetic division, you can, but hopefully we remember that that is a difference of cubes. So I can factor this by square the first, change the sign, multiply, square the last. So then from here, my goal was not to factor though, my goal was to find the zeros. So since x minus 4 is a factor, I know that x equals 4 is a zero. And I do know that this polynomial does not factor. What I know about that polynomial, though, is that I can find the zeros that are from it, even if those zeros are complex. So I can use either completing the square or quadratic formula. I'll go ahead and do completing the square just because I feel like we do quadratic formula a lot more often. So I'm going to go ahead and add my blank to both sides. The value that goes in the blank is 4 divided by 2 squared. So that gives me x plus 2 squared is equal to negative 12. Well, I can square root both sides. So this would be plus or minus the square root of negative 12. And the square root of negative 12, I can rewrite as 2i root 3. Then to get x by itself, I would just subtract 2. And I have my other two zeros. So if you'll notice, this was a third degree polynomial, and I had 3 zeros. X equals 4, negative 2 plus 2i root 3, and negative 2 minus 2i root 3. All right, so then we're going to go to B. So this is a fourth degree polynomial, so I'm going to go ahead and do a difference of squares because I have two terms, I know the square root. So this would factor into x squared minus 4 and x squared plus 4. X squared minus 4 is x plus 2x minus 2. X squared plus 4 does not factor. So to get my zeros, I've got negative 2 and 2. And then x squared plus 4 doesn't give me zeros, but I can solve it. So I would get x squared equals negative 4. So then I would square root. So this would be plus or minus the square root of negative 4, which is plus or minus 2i. So again, fourth degree polynomial, and I get 4 solutions, which leads us into our fundamental theorem of algebra. So basically, the fundamental theorem of algebra tells us whatever the degree is, that's how many zeros that function is going to have, as long as we include complex solutions and we include multiplicities of a number. So remember, multiplicities is the factor of that number. So like if it was x minus 3 to the 5th power, then 3 would have a multiplicity of 5. So the exponent of that factor is my multiplicity. And then one of the other things we talked about when we did quadratics, imaginary zeros and irrational zeros come in pairs. So if 3 minus the square root of 7 is a 0, 3 plus the square root of 7 is a 0. If 3 minus I is a 0, 3 plus I would also be a 0. So to write these equations, it's going to be very similar to what we did with quadratics. It's just going to be more factors because it's a polynomial. So this tells us to write a polynomial of least degree, and we are going to write this in standard form. It says to write, we have the 0 of 3 with a multiplicity of 2. And then I have the square root of 7. Well, if square root of 7 is a 0, so is negative square root of 7, which means that x minus root 7 is a factor and x plus root 7 is. So I'm going to go ahead and FOIL that out. That's going to give me x squared, difference of squares, the middles cancel, and I get x squared minus 7. If I FOIL out x minus 3 cubed, I get x squared minus 6x plus 9. And then I can go ahead and multiply out this whole thing. So x to the 4th minus 7x squared minus 6x cubed plus 42x plus 9x squared minus 63. Combine my like terms, and I get my polynomial, which would be x to the 4th minus 6x cubed plus 2x squared plus 42x minus 63. So it's a little bit messy on the algebra, but it's the same process that we did back with quadratic. All right, very similar in the next one. It only tells us that 3i is a root, but if 3i is a root, negative 3i is a root. So x minus 2 would be a factor, x minus 3i, and x plus 3i. Well, I'm going to go ahead and multiply these two together and FOIL those out because it's a difference of squares, so it's going to be pretty easy. The middles will cancel. X squared minus 9i squared is what's left. And if you remember, 9i squared, that would be the same thing as a negative 1. So this is x minus 2 times x squared plus 9. I can go ahead and FOIL that out, and I'll get x cubed minus 2x squared plus 9x minus 18. All right, so then we'll look at a couple that are just a little bit harder, but again, very similar to what we saw back with quadratics. So 5 is a root, which means x minus 5 is a factor. 2 minus root 3 is a root. Well, if 2 minus root 3 is a root, so is 2 plus root 3. And we talked about how there's two different ways you can do this. One way is you can do x minus 2 minus root 3 and x minus 2 plus root 3. And you can FOIL it out just as we've been doing. If you do it this way, remember the sign here does not change. Where the sign changes is because it's the conjugate, so it's where the in between the square root and the number, that's where we change the sign. But the other way that you can do this is you could say that x equals 2 minus root 3, and then you can get this moved, and then you can square both sides. So I get x squared minus 4x plus 4 equals 3. So x squared minus 4x plus 1 is the factor, basically, that leads to those two zeros. Well, then from here, to find my final polynomial, I need to multiply this by x minus 5. So multiply that out, I get x cubed minus 4x squared plus x minus 5x squared plus 20x minus 5. And then I get my polynomial. And I'm done. All right, last one. Again, same type of process. X minus 1, x plus 2. If 3 plus I is a root, so is 3 minus I. Now on this one, I'm going to work this one out a little bit different. So we'll do x minus 3 plus I and x minus 3 minus I. And I want you guys to see one other way that you could work this out. So if I were to FOIL out those last two polynomials, what I could do instead is just group these in kind of a easier way. If I group them like this, as opposed to the way they really probably are grouped, what this creates now is a difference of squares. So this might just be a little bit easier to FOIL this out if this is the method you use. Because now, if I do x minus 3 times x minus 3, well, that would give me x squared minus 6x plus 9. But then my middles here, this one and this one, those are a difference of squares. Those middles are going to cancel out. So then I would just have minus I squared, which we know is the same thing just as plus 1. Now that's the same thing I would get if I worked it out the other way. So I would get x squared minus 6x plus 9 equals negative 1. So I end up with the same polynomial. It's just a different way of getting there. And again, whatever method makes the most sense for you, go ahead and do it. So let's go ahead and FOIL out the two on the left. So that's x squared plus x minus 2. And then that would be x to the 4th minus 6x cubed plus 10x squared plus x cubed minus 6x squared plus 10x minus 2x squared plus 12x minus 20. Combine your like terms. So that would be x to the 4th minus 5x cubed. Then I've got plus 4x squared plus 22x minus 20. right, so again, that's just an extra example. All right, so again, looking back at what we did back in quadratics, this time we're going to have all these other questions we've been able to assume the leading coefficient is 1. Well, and this is a case where we're not able to do that. So what I need to do then is I need to write my with these zeros. So if my zeros are 0, -1, 2, and -3, those are my factors. If I want, I can go ahead and multiply this out. And then I'll FOIL all this out, so x to the 4th plus x cubed minus 6x squared plus x cubed plus x squared minus 6x. And then I get my polynomial, and it's in standard form. The problem here, though, is even though it's in standard form, it doesn't work for the other criteria that I was given, which was that f of 3 equals 288. So this is a case where I can't assume that that a value is 1. So if that a value is out there, I need to find what it is. Well, that value, let's go ahead and solve for it. So 288 is equal to a, and then what I'm plugging in for x is 3. So 3 plus 1 is 4. 3 minus 2 is 1. 3 plus 3 is 6. So I get 288 equals 72a. So I get that a is equal to 4. So if a is equal to 4, we're multiplying all of this by 4. And that is my polynomial. So again, if you're given other information, we got to solve for that a value. And remember, when multiplied by the entire polynomial. Okay, we have to distribute it to all those terms that we get. All right, so the last question we're going to look at here is probably one of the harder ones. It's just because the way you probably would want to do it is not the easiest way to do it. So we know that 2 minus I is a root. That means we know that 2 plus I is a root. So the way you may want to do this is to go ahead and use synthetic division. So if I do synthetic division with 2 minus I can do that. That will work. But it gets really messy because we're going to be multiplying that by numbers and foiling and doing all sorts of things. It gets a little bit complicated. So what I'm going to do instead is use what I know. If 2 minus I is a root, I'm going to find the corresponding factor that goes with that. Well, then I would do x equals 2 minus I, or 2 plus or minus I. Square both sides. I squared is -1. And that is the polynomial, or the factor, that would give me both of those roots. So that does not factor any farther from that, so that's the factor that gives us those roots. Well, in order to find the other factors, what I can do then is just long division. So I'm going to do x squared minus 4x plus 5 and divide that into this polynomial. So if I divide that into that polynomial, that would give me x squared then I would subtract, which means I'm going to change my signs. So I have x cubed, that becomes minus 10x squared plus 5x minus 6. That would give me plus x, multiply, and I'm going to subtract. So I'm going to change my signs. So that gives me negative 6x squared minus. And in case you're wondering why this isn't working out nicely, it's because I forgot that I changed your answer on your notes and I didn't change it on the video. So let me rework that real quick for you guys. Sorry about that. So if you look at your notes, you have a different polynomial there. You have one that actually works out well. So the one that's on your notes is x to the 4th minus 5x cubed plus 3x squared plus 19x minus 30. And this is one that will actually divide much nicer for us. So the process doesn't change, but this is an answer that actually will factor evenly for us. Okay, so now, doing this again, I'm going to get x squared. I'm going to subtract. So that becomes negative x cubed minus 2x squared minus 19x, which means that I would then have minus x, multiply that across, subtract, and then do it again. That's going to be minus 6. And when I distribute now, I should write my problem down correctly because that was positive right there. So that's 24. Sorry about that. So now I get a remainder of 0. Since I get a remainder of 0, that means that basically this polynomial factors into the original divisor, x squared minus x minus 6. So that would be x squared minus 4x plus 5, x minus 3, and x plus 2. All right, now if you want to do that with synthetic division, you can. You would just need to remember that 2 minus I and 2 plus I are both roots. If you want to see that worked out, the notes on Schoology do have it worked out with the synthetic division in case you want to see that option.